So exercise 6. The demand for snorkels in Burhama is given by 500 minus 8 times PS, and the supply of snorkels in Burhama is given by 200 plus 4 PS. The demand for kayaks is given by 650 minus 6 times PK, and the supply of kayaks is given by 50 plus 1.5 times PK. And now, please keep in mind that because we have two different goods, we have snorkels and kayaks, we have an index here for the prices and the quantities, so denoting the particular good that we're talking about. Both goods are currently untaxed, but the government of Burma needs to raise $5,000, and this is wrong. I will update this also in the solution manual. So I uploaded the problem set and the solutions with the wrong value here. So I will update both of them. So this is supposed to be 150. So it needs to raise $150. Okay, this should be a dollar sign, but yeah, think of the dollar sign just like this. So to finance a new lighthouse by taxing snorkels and kayaks, what tax should it levy on each of the two goods? So here it means that basically, how should it tax in the most efficient way, so to minimize deadweight loss in order to raise $150 of taxes. Okay, so this will be a little bit more demanding than what we have been doing before, because here we have to calculate the efficient taxes, and the taxes are not given. Okay, so this will be a little bit more demanding here. So let me just go back. So let's start with snorkels. So if, or for tax T of S, so I will write an S in index to denote that this is a tax on snorkels. T is on snorkels. What we have is the following. So if you want to calculate the equilibrium price for a given tax on snorkels, we simply set the demand function equal to the supply function. So 120 minus 6 times PS. This should be equal to 40 plus 5 times PS. So this is the supply function, and where we consider that from the price we subtract the taxes which the suppliers need to pay to the government. So PS times TS now. And if you solve this, you get PS. So the price, equilibrium price on snorkels is equal to 80 divided by 11 plus 5 divided by 11 times TS. Yeah, so the main difference now from this exercise compared to the other exercise is that here the prices and the quantities will depend on the tax that we impose on the goods explicitly. Yeah, so they're not given the taxes, but we have to calculate them. So this part here is basically new. Okay, now given that we have the price depending, the equilibrium price depending on taxes, the quantity, so QS is then equal to 120 minus 6 times, then we simply substitute for the price and we get 80 divided by 11 plus 5 divided by 11 times TS. And if we can simplify this to get the following quantity depending on the tax. So it's 840 divided by 11 minus 30 divided by 11 times TS. So the quantity of snorkels will depend on the tax on snorkels, and it's given by this expression here. Okay, so one thing that you can already see is that if there is no tax on snorkels, the equilibrium quantity will be 840 divided by 11. And what we will be doing now is, in order to derive optimal taxes or most efficient taxes on snorkels and kayaks, what we need is we need to compare the marginal tax revenue that we get due to taxes on snorkels with the marginal deadweight burden of an increase in taxes. Yep. So we need to calculate those two expressions, and that's why we needed to derive the equilibrium prices and the equilibrium quantities depending on the tax on snorkels. So the deadweight loss. So the deadweight loss on snorkels. So I will set an index here. Is then the following. So it's 1/2 times the tax on snorkels. So that's TS times the change in quantity due to the tax. And without tax, we would have, or without taxes, we would have 840. With taxes, we would have 840 minus 30 divided by 11 times TS. Therefore, if we subtract the expressions from each other, we end up with the following. So the change in quantity of snorkels, so the change in equilibrium quantity of snorkels due to the tax on snorkels is then simply 30 divided by 11 times TS. Okay, and this is the deadweight loss due to a tax on snorkels. If it's zero, so if the tax is zero, then we do not have any deadweight loss on snorkels, so no market of snorkels, and it's increasing with higher or with increasing taxes on snorkels. Now, given that we have the deadweight loss, we can calculate the marginal deadweight loss, which is then simply the derivative of the deadweight loss with respect to the tax on snorkels. So marginal deadweight loss, this is simply the derivative of the deadweight loss snorkels with respect to the tax on snorkels. And yeah, this is then, so if you, let me just be precise here. So this is 1/2 times TS by the power of 2 times 30 divided by 11. So this is the deadweight loss. If you take the derivative, you bring down the 2 here in the exponent, and hence the deadweight loss is 2S times 30 divided by 11, because the 2 gets cancelled out with the 2 in the denominator. Yeah, so this is the marginal deadweight loss on snorkels. Then what we also need is the tax revenue. So the tax revenue will be denoted by TR. So yeah, let me just write it down once, and then we shortcut it by TW. So TW is the tax revenue on snorkels, which is then simply, yeah, the tax on snorkels multiplied by the quantity in equilibrium. So it's not the quantity in equilibrium, sorry. It's yeah, it's the quantity in equilibrium, so it's TS, or 840. If you simplify it, it's 840 divided by 11 times TS minus 30 divided by 11 times TS squared. Okay, this is the tax revenue and the marginal tax revenue. So marginal, oh, this shouldn't be a W here, sorry. It should be, of course, it should be TR. So tax revenue on snorkels. So the marginal tax revenue, so marginal TRS, is then equal to the derivative of the revenue, the tax revenue on snorkels with respect to, yeah, the tax on snorkels. So we're simply taking the derivative here. And by doing this, we get 840 divided by 11 times, not times something, it's then minus. Then if we take the derivative of this part here with respect to TS, it's then simply 60 divided by 11 times TS. Okay, so the marginal tax revenue, if you marginally increase the tax revenue, the taxes on snorkels is given by this expression here, and the marginal deadweight loss, if we increase the taxes on snorkels, is given by this expression here. And those will be two components which will be important. So now we need to do the same thing for kayaks. So kayaks, and I will shortcut some of the steps because they are similar. So you calculate then the equilibrium quantity and the equilibrium price. And this is what you will be needing to calculate the deadweight loss, which then will be given by the following. So the deadweight loss on kayaks is given by 1/2 times the taxes on kayaks times the change in quantity due to the tax, which for kayaks will be 20 divided by 9 times TK. Okay, so in total, what we have is then 1/2 times TK by the power of 2 times 20 divided by 9. So this will be the deadweight loss for kayaks. And then if we take the derivative, the marginal deadweight loss, so the marginal deadweight loss of kayaks is then simply again the partial derivative of the deadweight loss of kayaks due to an increase in the taxes on kayaks. And this is then simply 20 divided by 9 times TK. Now we need to calculate the tax revenue from kayaks. So the tax revenue is then here simply TK. Sorry, I'm always writing TK. That's very confusing. It should be TR here. TR of K. So the tax revenue on kayaks is equal to the tax on kayaks times the quantity in equilibrium, depending on the tax price. And this is equal to 40 times TK minus 20 divided by 9 times TK by the power of 2. Now that we have the tax revenue, we can calculate the marginal tax revenue. So the marginal tax revenue then is again the derivative of the tax revenue for kayaks if we, with respect to tax on kayaks. And this is then 40 minus 40 divided by 9 times TK. And here the marginal deadweight loss and the marginal tax revenue, those will be the two important components that we need in order to derive the most efficient taxes in this economy. So optimal taxes, so optimal in the sense that we want to minimize the deadweight loss if we have the goal of getting a tax revenue of $150, then the optimal taxes need to fulfill the following condition. So optimal taxes must equate the ratio of the marginal deadweight loss to the marginal revenue for both goods or for the goods. So in words, the following must be fulfilled. The marginal deadweight loss of snorkels divided by the marginal revenue of snorkels. Oh, let me shortcut this. It's a little bit too long here. Okay, I think I didn't introduce a shortcut before, so never mind. I will just write it down like this. So the marginal deadweight loss of snorkels divided by the marginal revenue of snorkels, or the marginal tax revenue, of course, should be a tax here. Marginal tax revenue of snorkels. This should be equal to the marginal deadweight loss for kayaks. So we write down a K here. And yeah, divided by the marginal tax revenue of kayaks. Okay, so this is in words what I will be doing now. So now I will insert all the values that we calculated before, and we end up with the following. So we end up with the following condition: 30 times TS. This was the marginal deadweight loss. 30 divided by 11 times. Okay, this looks a little bit ugly. Let me just rewrite. 30 times 11 times TS divided by, so this is the deadweight loss, the marginal deadweight loss of snorkels divided by the marginal tax revenue of snorkels. So 840 divided by 11 minus 60 divided by 11 times TS. This should be then equal to the marginal deadweight loss on kayaks, which was given by this expression here, and we divide this by the marginal tax revenue on kayaks. Now you can solve this, and what you then will basically get is that if you solve this, you will get 9 times taxes on snorkels is equal to 14 times taxes on kayaks. And if you then solve it for one of the variables, for instance, now what we will have is that if we solve this for the taxes on snorkels, we get taxes on snorkels is equal to 14 divided by 9 times TK. And this is giving us the optimal or the most efficient ratio of the two taxes that we need, like our tax system needs to fulfill in order to derive any amount of total tax revenue that we wish. Yeah, so this ratio here does not depend on the total amount of revenue that we want to generate, but it will basically always be a condition for efficiency. Yeah, so this condition here does not depend on how much taxes we want to generate, like how much tax revenue we want to generate, but it's telling us that this is the most efficient way to do it. So if the taxes on kayaks are equal to 1, then the taxes on snorkels should be 14 divided by 9. That's the idea here. And since we know this ratio, what we can now calculate is the total revenue because then we can solve this. So we'll have the total revenue, which of course depends on the two taxes. But since we know the most efficient ratio of the two taxes, we can substitute in this total revenue for one of the variables, and then we can solve one equation in one unknown, which will be quadratic, as you will see. So the total revenue is simply adding up the revenues of the both for the both goods. So total revenue is then the total revenue of snorkels plus the total revenue of kayaks. And yeah, we can, let me write this down below because it will be quite a long expression, I think. So this is then, let me just recheck everything. So this is equal to 840 divided by 11 times TS minus 30 divided by 11 times TS by the power of 2 plus, so this is the total revenue of snorkels depending on the tax, plus now the total revenue on kayaks, which I will get 40 times TK minus 20 divided by 9 times TK by the power of 2. Okay, so this is the total revenue, which is the sum of the respective revenue of the goods. Yeah, and now what we can do, and this should be, this one thing missing here. So we want to raise a revenue of $150. So let me just make this a little bit smaller. So this here should be equal to 150. Okay, so this is the tax revenue that we want to generate. And now we can basically, in the next step, substitute for TS here. So we substitute for TS the ratio that we just described here. So we basically plug in for each of the TS here, 14 divided by 9 times TK. And then we end up with an equation which solely depends on decay. Let's do this. So what we then get is 840 divided by 11 times 14. 14 divided by 9 times TK minus 30 divided by 11 times 14 divided by 9 by the power of 2 times TK by the power of 2. So I'm simply substituting the expressions here, plus 40 times TK minus 20 divided by 9 times TK by the power of 2. This should be equal to 150. So this is what we need to solve, and this is a quadratic equation. And one of the solutions, if you solve this, so you can use Wolfram Alpha in the internet. So you simply plug in Wolfram Alpha in Google, and then you plug in this equation here. And instead of TK, you simply choose an easier variable, for instance, X, which you then, then you solve this equation, and then what you will get is one of the solutions will be that TK star is roughly equal to 1. Okay, so TK star is roughly equal to 1, and therefore, since we know that if the tax on kayaks will be equal to 1, what we derived before is that then the tax on snorkels is 14 divided by 9 times the taxes on kayaks. So TS star is then roughly equal to 14 divided by 9. And this is basically the solution. So there is one more solution to this quadratic equation, but I just gave you one of the two here. Yeah, the one which has the lowest taxes, because this will be the least, the most efficient one. So yeah, if the government wants to tax the two goods in the most efficient way to raise taxes or a tax revenue of $150, it should put taxes of $1 per unit on kayaks and 14 divided by $9 units on snorkels. This is basically the answer to the question. And as I said before, there is a mistake in the solution PDF that I updated, which I will correct. So you basically have a consistent solution PDF with what I showed you here. And this brings us to the last exercise. So exercise number 7. The government of Granita is thinking about imposing a very small tax on one or more of the following goods: anvils, books, and cardigans. Anvils and books are both produced in competitive markets with constant marginal costs, while cardigans are produced by a monopoly with constant marginal costs. The elasticities of demand for the three goods are -3, -1.5, and -1.2 respectively. What good or goods should the government put the very small tax on if it wants to minimize the deadweight burden? Okay, so this is then question number 7. So the taxes should be put on both anvils and books, but not cardigan. Yeah, so taxes should be, or yeah, this is confusing language. Let me rewrite. So it should tax, so the government should tax anvils and books, but not cardigans. Okay, and you might ask yourself, so why is this the case here, even though the demand for so the elasticities of anvils and books are highest here, so in absolute terms, relative to cardigans. So before we said that if something is highly inelastic, highly elastic, we shouldn't put too much taxes on it. But here the story is different because here the market in which the three different goods are kind of sold or traded at differ. So anvils and books are basically traded on competitive markets. Okay, and competitive markets, if I mean under some assumptions, produce welfare kind of maximizing a welfare maximizing situation. So if you then put a very small tax on goods which are traded in competitive market, the deadweight burden or the marginal deadweight burden is very small, yeah, because first of all, the tax is very small, and we are very close to a welfare maximizing situation. So the marginal tax rate or the marginal deadweight burden, deadweight loss, the marginal deadweight loss from a small tax on a good in a competitive market is very small. Okay, so because it's a small tax and because we are engaging in a competitive market. So we start from a situation where we have kind of basically the either no or the least possible amount of deadweight loss. Now, That's the situation for anvils and books. But what about the situation with cardigans? So the cardigans are produced from a monopolist. Okay, and the issue there is that in a monopoly, the the quantity or the output which is produced in the social compared to social optimum is lower. Okay, so in a monopoly, the output of cardigans is already below the social optimum. Okay, so in a competitive market, we are at the social optimum, and in a monopoly, we are already in a situation where we are below, the output is below of the social optimum quantity that we would have in a competitive market. Therefore, if we are already below the social optimum, a small tax increase, on cardigans would further increase the deadweight loss. As a consequence, what we should do is we should kind of tax the both goods which are produced in the competitive market equally and subsidize the monopoly good. So the most efficient way, so what you should do is to equate marginal deadweight burden or deadweight loss on goods which are competitively produced because, as I said before, the changes in the deadweight loss will be quite low here. But on the other hand, what you could do then, if you have taxes on books and anvils, you could use these taxes to subsidize the monopoly sales to come closer to the social optimum of output in the market of cardigans. So you should equate the marginal deadweight loss on goods which are competitively produced and subsidize the monopoly or the good which is produced by the monopolist. And this is the answer to the question. And with this, we are done with this week's exercise session. So if I'm not mistaken, next week there is no holidays, so we will have an exercise session next week. As usual, if you have questions, please let me know, write me an email. And yeah, keep in mind my remark that I made before, that there was a slight mistake here in exercise number 6, which I will adjust in the solution manual that I think I already uploaded on Moodle. Yeah, see you next week.